Hello friends, in previous lecture we discussed the structure and shapes of alcohol. After that we focus on isomerization, in which chain isomerization, position isomerism or the functional isomerism. After that we discuss the general methods of preparation of alcohol, and the most important method is the Grignard reagents. That means by using a Grignard reagent we can prepare a alcohol. Then reactions of Grignard reagents, in which formaldehydes yield primary alcohol while the aldehyde yield secondary alcohol, and in case of ketone yield tertiary alcohol. That part discussed in previous lecture. After that the ethyl formate yields the secondary alcohol, but the other ester yield tertiary alcohol on reaction with excess of Grignard reagent. That part cover in a previous lecture. Today we will start the remaining part of alcohol, that is ester hydrolysis. Ester hydrolysis is having two types, that means the acid ester hydrolysis or the base ester hydrolysis. It yield alcohol and acid. That means the ester, it undergoes hydrolysis, is formations of the alcohol and acid as a final product. In first reaction, this is the structure of ethyl acetate plus HCl plus H2O. That means this is the acid hydrolysis. And acid hydrolysis, we get the ethyl alcohol plus acetic acid. That means the ethyl acetate, it undergoes acid hydrolysis, is formation of ethyl alcohol plus acetic acid. In second example, this is the structure of propyl acetate plus NaOH plus H2O. That means this is the base hydrolysis. That means this propyl acetate, it undergoes the base hydrolysis. The product is alcohol plus sodium acetate. That means here propyl alcohol plus sodium acetate. We add H plus, we get the sodium, or we get the acetic acid. Simply we get the acetic acid. That means this is the acid hydrolysis and this is the base hydrolysis. The final product is alcohol plus acid. And in second example here, ethyl benzoate on treatment with HCl plus H2O. That means HCl plus H2O. HCl is the acid. That means it is the acid hydrolysis, and the product is benzoic acid plus alcohol. That means we get here benzoic acid plus ethyl alcohol as a final product. We have to remember ester, it undergoes hydrolysis. The product is alcohol plus acid, and the longest chain containing alcohol while the shortest chain containing the acid. And the ester hydrolysis is having the two types, that means acid ester hydrolysis or the base ester hydrolysis. Both it undergoes hydrolysis. We get the final product is alcohol plus acid. Okay, next, the reduction of aldehyde, ketones, acids and ester. Here the reduction of aldehyde, ketones, acids and ester. The first point is reduction of aldehyde and ketone. The reduction of aldehydes on reduction with a variety of reducing agent such as LiAlH4, that means lithium aluminum hydride, NaHg, sodium amalgam, H2 in presence of nickel, or NaBH4, that yield the primary alcohol, while ketone gives secondary alcohol. That means aldehyde, it undergoes reduction, we get the primary alcohol, while the ketones on reduction we get the secondary alcohol. Here the first example is the acetaldehyde plus LiAlH4, that means lithium aluminum hydride. This lithium aluminum hydride, it is a source of the hydride. It will be attack on this carbonyl, and this aldehyde, it will be reduced, we get the primary alcohol. Aldehyde undergoes reduction, we get the primary alcohol, and here the name of the compound is ethanol. If we take acetone, CH3 C double bond O CH3 acetone plus NaHg, that means sodium amalgam plus H2O, the final product is the secondary alcohol, and it is nothing but the isopropanol. Okay, now here next example, pH C double bond O CH3, that means this is ketone, plus on treatment with the NaBH4, that means sodium borohydride. Sodium borohydride is the base reducing agent. It is again a source of hydride. This will be attack on this carbonyl and it undergoes reduction, and here we get the pH CHOH CH3, that means we get the secondary alcohol, because ketone it undergoes reduction, we get the secondary alcohol. Next here benzaldehyde. Benzaldehyde plus H2 in presence of nickel. Benzaldehyde H2 in presence of nickel, that means the catalytic reduction of this benzaldehyde, we get the primary alcohol, and this primary alcohol is the benzyl alcohol. Then next, the reduction of acids and esters. That means reduction of acids and ester. Acids and esters are also reduced by the strong reducing agent like lithium aluminum hydride. And we know that the lithium aluminum hydride, it is a strong reducing agent. After reduction, we get the primary alcohol. Here, ethyl acetate plus lithium aluminum hydride, we get the ethanol. That means after reduction, we get the alcohol. And second, benzoic acid plus lithium aluminum hydride, we get the benzyl alcohol. That means in first example, this is ethyl acetate, that means ester, it undergoes reduction, we get the alcohol. In second example, benzoic acid, that means acid, plus lithium aluminum hydride, it undergoes reduction, we get the benzyl alcohol. Now the next, reduction or hydrogenation of carbonyl compound. We just summarize this point. The method of preparation of alcohol, here the reduction or the hydrogenation of carbonyl compound, having two types, that means catalytic hydrogenation and by using nascent hydrogen 2H. Here the carbonyl, it will be converted into the CHOH, that means here it is a simple reduction. That means carbonyl is converted into CHOH, that means it is nothing but the reduction. Now then, if we take a formaldehyde, or it is called as the methanol, plus H2 in presence of nickel. H2 in presence of the nickel, it is the catalytic hydrogenation. Here the reduction of this formaldehyde, after reduction, here we get the primary alcohol, and it is called as the methanol. Now second example, this is the acetaldehyde, or it is called as the ethanol, plus H2 in presence of nickel, it is heated at 413 Kelvin, and here we get the CH3 CH2OH, that means the ethanol. Again here we get the a primary alcohol, that means the formaldehyde, then acetaldehyde, treatment with the H2 in presence of nickel, it is a simple reduction, we get the primary alcohol as a major product. Okay. Now the next, suppose if we take ketone, that means the best example acetone, it is called as the dimethyl ketone or the propanone, plus H2 in presence of nickel at 413 Kelvin. Here ketone, it undergoes reduction by using H2 in presence of nickel, and we know that the ketone, if we reduce the ketone, we get the secondary alcohol, and here formation of this secondary alcohol, it is called as iso or the isopropyl alcohol or the secondary alcohol, or sometimes it is called as the propane 2-ol. It is the secondary alcohol. That means ketone, it undergoes the reduction. There is formation of secondary alcohol. We have to remember ketone, it undergoes reduction, formation of secondary alcohol. Now then here formaldehyde, by using the innocent hydrogen 2H, sodium amalgam plus H2O, or by using NaBH4 or LiAlH4. NaBH4, that means sodium borohydride or the lithium aluminum hydride. It is the best reducing agent. It reduces the aldehyde into a primary alcohol. Similarly, if we take acetaldehyde plus 2H, innocent hydrogen, sodium amalgam H2O, and here we get the ethyl alcohol. Then ketone, it undergoes reduction by using innocent hydrogen, sodium in presence of Hg, that is sodium amalgam plus H2O, we get the a secondary alcohol, formation of secondary alcohol. That means we have to here clear that aldehyde, it undergoes reduction, we get the primary alcohol, while the ketone, it undergoes reduction, we get the secondary alcohol. Here the note is that we have to remember aldehyde gives primary alcohol on reduction, while the ketone gives secondary alcohol on reduction. Then tertiary alcohol cannot be prepared by reduction. You have to remember this point. The lithium aluminum hydride, it is an expensive reagent, so used for preparing the special chemical only, and acids are reduced to alcohol by converting them into ester followed by their catalytic reduction. That means the acid, it will first convert into ester, then it will be reduced, then directly it will be converted into catalytic reduction. Here this is the acetic acid CH3 double bond OH plus 4 nascent hydrogen in presence of lithium aluminum hydride. Lithium aluminum hydride is the reducing agent, therefore there is a reduction of this acid and we get the primary alcohol, that is CH3 CH2OH, that is ethanol. We have to remember that lithium aluminum hydride is the base reducing agent, therefore reduction of this acetic acid we get the alcohol. Or if anyone asks the question, how will you convert acid to alcohol? It's very easy, just by using the lithium aluminum hydride. Here general R C double bond OH plus ROH, that means this is the acid and this is alcohol. Nothing but the esterification. Here H plus, here OH, and here hydrogen, OH from acid and hydrogen from alcohol, plus the byproduct is H2O, and there is formation of ester. It is called as the esterification. That means the acid plus alcohol, we get the ester. Then in next step, the ester on treatment with the 4 nascent hydrogen, that means the reducing agent, lithium aluminum hydride, ester, it undergoes reduction, we get the a primary alcohol, that is RCH2OH plus alcohol. This is the carboxylic acid, RC double bond OH, and this is alcohol, and we get ester, and this ester, it undergoes the reduction by using lithium aluminum hydride, we get alcohol. The cyclohexanone, it undergoes the reduction, we get the cyclohexanol. If anyone asks the question or in exam, if they ask how will you convert cyclohexanone to cyclohexanol, just by using one of the reducing agent or the it undergoes reduction And for reduction we use the reducing agents such as lithium aluminum hydride, that is LiAlH4, or NaBH4, or H2 in presence of nickel. Here the cyclohexanone is converted into cyclohexanol, it is reduction, and when we convert the cyclohexanol to cyclohexanone, it is oxidation. It is a irreversible reaction. That means the cyclohexanone is converted into cyclohexanol, that means the reduction, while the cyclohexanol it is converted into cyclohexanone, it is oxidation reaction. Next, the properties of alcohol. First, we discuss the physical properties of alcohol. The lower members are colorless liquid and have a distinct smell, while the higher members are solid and almost colorless. That means here we have to remember that the lower members of alcohols are colorless liquid and the higher members are solid. Lower members of alcohol are soluble in water, or solubility decreases with increase in the molecular weight. That means molecular weight increases, the solubility will be decreases. Next, the alcohols have high boiling points and that of the corresponding alkane, that is alkyl halide, aldehyde, ketones, or ether, due to presence of the intermolecular hydrogen bonding. Or simply the alcohol have high boiling point. Explain why. Due to presence of intermolecular hydrogen bonding. Here the skeleton of this alcohol, and here we are showing the hydrogen bonding. It is called as the intermolecular hydrogen bonding. I have shown here by arrow. This is OH, on this OH, that means dotted line. It is the intermolecular hydrogen bonding. Due to formation of the intermolecular hydrogen bonding, alcohol have high boiling points. Next, such a hydrogen bonding is absent in alkyl halide, aldehyde, ketone, and we require more energy to break this bond in case of alcohol. Therefore, alcohol have more boiling point than that of the corresponding alkane, alkyl halide, aldehyde, and ketone. Then the boiling point of alcohol increases with increase their molecular weight. Here the most important is that a branch chain alcohol have low boiling point. The branch chain alcohol have low boiling point due to a weak van der Waals forces. While the alcohols are a neutral to the, if we take the test, that is alcohols are neutral to litmus, then alcohols are acting as a Bronsted acid as well as the Lewis bases. Therefore, they are reactive. What is the meaning of the Bronsted acid? Bronsted acid, that means we use the H plus ion. Actually, Bronsted acid, it is a Bronsted theory, and in case of Lewis base, that means Lewis acid base theory. Lewis base, that means the which donate the electron pair. Therefore, the alcohols, it acting as a Bronsted acid as well as the Lewis base. Therefore, it is the most reactive.